Selamat datang semua. Nama saya Mina Terai. Saya sayang kamu. From Japan, and we are so happy to have opportunity to make our presentation here, and so please rest and feel free to ask questions and enjoy our presentation. Okay, let me start with my presentation. I did a research last year with my group mate, and the theme was relationship between lipid production and life conditions of Microalgae Chlorella. Okay, as you can see in this photo, there are many kinds of Microalgae, and it produces lipid, oil, or hydrocarbon inside their cells, and it can be used as biodiesel. So now we need more new energy resources. So it's so popular in the world. Many companies or university research about it. And we chose Chlorella. There are many kinds of Microalgae, but among them we chose Chlorella as our sample. That is because it's easy to culture and it has a good photosynthesis capacity. Okay, let me explain about the mechanism of lipid production. When the light shifts to Chlorella, as you know, as photosynthesis, they produce starch inside the cells. But when they go pressed, the amount of starch decreases and the amount of lipid increases. So starch and lipids are in trade-off relationship. Here is some examples of spreads that we know from previous research. Okay, I'll tell you our purpose. Our purpose was to research optimum therapeutic conditions for the lipid production of Chlorella. We focused on therapeutic conditions. If we increase the lighting time, photosynthesis is carried out vigorously, then multiplication becomes vigorous. But if we increase the light out time, photosynthesis isn't able to be carried out, and it's stressful for multiplication of Chlorella, and the lipid production increases. We combine these conflicting conditions and try to find the optimum conditions. Okay, so next, this slide shows the species of Chlorella that we use and culture way that we did. Now I stand for lighting time to capital L and light out time to capital D. So if I light Chlorella for 10 hours and put it in interface for 14 hours, I express it 10 L and 14 D. Okay. So here is the proof of the experiment. We cultured Chlorella and the therapeutic condition that was set for about 2 weeks, and then we compared populations and the lipid production of Chlorella in each condition relatively. Okay, so next I will explain about staining and extraction of lipid oil or liquid, using oil or liquid. The oil or liquid is the dye that stains lipid into red, and the spectrum is 540 nanometers. So we measure the absorbance at 540 nanometers Then compare the amount of lipid. This picture shows the flow of the experiment. We experiment in the order of quick, stain, extract, and compare. But here is the problem. Look at the left picture. As it's hard to see, there are lipid inside the cells, there are many cells, and as you can see, it's red. It's stained into red. But that was not extracted out of the cells, so we can't measure the absorbance. There are two constable causes, like this. And we made some improvements for this program and experimented again and again. First, we added tail days. Second, we grinded the Chlorella and crushed the cell wall. Third, we changed extracting solution to hexane. And we added these ways between addition of observation, then experimented again and again. This table shows the result. For example, when we use cellulase in grinding operation, then the dye was extracted well. But when we use only cellulase, the dye was not extracted. From this result, we can say three things. First, cellulase isn't enough to extract the lipid. And second, grinding operation is essential. And third, hexane doesn't work as an extracting solution. So as a result of this, we decided to use cellulase and grinding operation for the main experiment. Here we set the photoperiodic means like photoperiodic condition for the main experiment from these three reasons. And the condition is like this. Okay, next I'll show you the results. These green bars means the Chlorella population. Look at graph number 3. Chlorella culture and the condition number 3 is multiplicated the best. We think this is because the condition number 3 10 and 40 day is designed by National Institute for Environment Study. So this is suitable for multiplication. Okay. Next. Next. This red bar is the absorbance. So this is the amount of lipid. And these numbers mean the lipid production efficiency. Look at graph number 1 and 2 or 4 and 5. Number 2 and 4 is the number 2 and 4's lipid production efficiency is higher than number 1 and 5. Why did this happen? We think this is because the condition number 2 and 4 has switch of light. So like 1L is trying to switch of light, but number 1 and 5 don't have. So we think switching of light is stressful for Chlorella and it leads to increase the amount of the lipid production of Chlorella. Okay. So next, look at graph 2 and 3 and 4. All had a switch of light, but condition number 2 and 4's lipid production efficiency is higher. We think this is because the condition 2 and 4 have longer stable time, so 23D or 23L. So it will be more stressful when the light is switched. Okay. So from these results, we have two considerations. First, switching of light is stressful for Chlorella, and it improves lipid production efficiency of each Chlorella. addition, the longer writing time is, the more efficient the lipid production becomes. Second, long writing time increases covariance coefficient and it leads to increase the total amount of lipid. Okay, finally, I'll tell you our conclusion. Please remember, our research purpose was to find optimum therapeutic conditions for the lipid production of chlorella. So, in terms of lipid production efficiency, we concluded number 4, 20A1D is the best condition. And in terms of the total amount of lipid, condition number 3, 10L14D is the best. Okay, references are shown here. Thank you for listening. Okay, do you have anyone have questions or some advices? Please raise your hand. Feel free to ask questions.
Sedang.
Okay, I want to ask about, do you have a test any other species other than cholera to make lipid for biodiesel?
I didn't do experiment or any test about other creatures, but I read the previous research and we got idea from the previous researchers. Thank you. Any other questions? Maybe one more.
How long does it take for you to do this research?
Last whole year, 1 year. From April to March next year. So 1 year. Okay. The time is, so I'm sorry, so the time is limited. So, okay, if you have any other questions, ask me later. Thank you very much for listening.